Today, we are embarking on a journey 1,470 light-years into the constellation Cygnus to explore one of the most bewildering celestial mysteries ever uncovered by human astronomy, a star so strange in its behavior that it sparked global headlines, fired up conspiracy theories, and made even the most cautious scientists ask, could we have found evidence of an advanced alien civilization? This is KIC 8462852, better known as Tabby Star, or Boyajian Star, the faint, unassuming star that turned our understanding of stellar light curves upside down and gave life to the most famous alien megastructure rumor in modern space exploration. For nearly a decade, this single point of light in the dark sky has puzzled professional astronomers, citizen scientists, and space enthusiasts alike, and its story is one that blends careful cosmic observation, bold theoretical imagination, and the relentless human drive to answer the greatest question of all: are we alone in the universe? To understand why Tabby Star became a worldwide sensation, we first have to go back to the mission that discovered it, NASA's Kepler Space Telescope. Launched in 2009, Kepler's sole mission was to hunt for exoplanets, planets orbiting stars outside our solar system, using the transit method. The idea was simple. When a planet passes directly between its host star and Earth, it blocks a tiny fraction of the star's light, creating a predictable tiny dip in brightness. For years, Kepler stared at over 200,000 stars in a small patch of sky, recording their light curves with precision never seen before. And algorithms were programmed to spot the regular shallow dips that signaled a planet. But Tabby Star was nothing like that. It was found not by a computer algorithm, but by everyday people taking part in the Planet Hunters citizen science project, volunteers who pored over Kepler's raw data and noticed something no machine could have flagged as normal. What they saw was unlike any stellar behavior recorded before. Tabby Star didn't have small periodic dips. It had massive, erratic, unpredictable drops in brightness that defied every known natural explanation. In 2011, the star's brightness fell by 15% over 7 days. In 2013, it dropped by more than 22%, a staggering plunge that lasted for weeks, with multiple smaller dips scattered in between. To put that in perspective, even Jupiter, the largest planet in our solar system, would only block about 1% of the sun's light if it passed in front of it. A 22% dip meant whatever was passing in front of Tabby Star was colossal, non-spherical, and moved with no regular orbit. To make things even more confusing, historical, astronomical records showed the star had been slowly, steadily dimming for more than a century, a long-term fade that no stable main sequence star should exhibit. This combination of sudden deep dips and gradual long-term dimming left astronomers speechless. There was no known type of variable star, no planetary system, no stellar collision that could account for all these weird traits at once. The star was nicknamed Tabby Star in honor of Tabitha Boyajian, the Yale University astronomer who led the first formal study of its bizarre light curves. In 2015, Boyajian and her team published a groundbreaking paper that laid out the star's impossible behavior and admitted something extraordinary. They could not explain it with any standard astrophysical model. The paper was cautious, scientific, and focused on natural explanations, but it included one speculative idea that would ignite a media wildfire. Could the strange dimming be caused by an artificial structure built by an intelligent alien species? That idea was rooted in a concept first proposed by physicist Freeman Dyson in 1960. A Dyson swarm, or Dyson sphere, a massive array of solar energy collecting structures built around a star by a civilization advanced enough to harness its full stellar output. Such a structure would block huge amounts of starlight in irregular patterns, matching exactly what astronomers were seeing from Tabby's star. Almost overnight, the story exploded across global news outlets. Headlines screamed, "Has NASA found an alien megastructure?" and "Tabby Star proof of alien life." Social media buzzed with debates. YouTube videos exploded with theories, and even mainstream news channels covered the story as a potential first contact event. The appeal was obvious. Here was a cosmic mystery that wasn't hidden in complex equations or distant galaxies, but in a star we could observe with our telescopes, a mystery that touched on humanity's deepest curiosity about life beyond Earth. The alien megastructure rumor turned Tabby's Star from an obscure catalog entry into the most famous star in the sky after our own Sunday. But while the public embraced the thrilling idea, the scientific community reacted with extreme caution, rooted in the principle of Occam's razor always exhaust natural explanations before invoking artificial or alien ones. Astronomers immediately began testing every plausible natural cause to explain the star's weird dimming. The first leading hypothesis was a giant swarm of exocomets, trillions of icy comets, pulled into a chaotic orbit around the star, possibly after a gravitational disturbance from a passing star. These comets would create a dusty debris field that could block light irregularly. Another idea was that Tabby's star had recently collided with, or swallowed, a planet, leaving a cloud of planetary debris orbiting it. Some scientists suggested intrinsic stellar activity, like huge star spots or magnetic fields, causing uneven brightness, but the star's stable spectrum ruled out most internal variability. There was also the idea of a circumstellar debris disk, a disk of dust and rock fragments left over from the star's formation, warped or clumped in a way that created the dips. Each of these theories had flaws though, and none could fully explain both the sudden 22% dips and the century-long slow fade. Then came critical observations from NASA's Spitzer Space Telescope, the Swift satellite, and ground-based observatories that delivered a major blow to the alien megastructure theory. Researchers found that Tabby's star dimmed much more strongly in ultraviolet and blue light than in infrared light, a wavelength-dependent effect that is a clear signature of tiny dust particles, not solid objects like planets or giant metal megastructures. Solid objects block all wavelengths of light equally, but fine dust scatters shorter wavelengths, more exactly what was measured. This was the strongest evidence yet that the dimming was caused by cosmic dust, not alien technology. Later observations from the James Webb Space Telescope added more detail, detecting fine, carbon-rich dust grains orbiting the star in an uneven, clumpy cloud that matched the light curve patterns. The long-term dimming, meanwhile, is now thought to be caused by a broader, thinner dust disk that slowly passes between the star and Earth over months and years. But even as the dust hypothesis became the leading explanation, Tabby's star refused to give up all its secrets. Some of the sharp, short dips still don't perfectly align with simple dust cloud models, and a small number of astronomers continue to study more exotic natural mechanisms, including stellar magnetic avalanche effects, dynamic processes near a phase transition that create chaotic light changes similar to what's seen in Tabby's star. What makes this star so special, even without aliens, is that it has forced astronomers to rethink how dust, debris, and stellar systems behave in ways we never considered before. It has pushed the limits of our telescopes, our models, and our creativity, reminding us that the universe is full of phenomena we haven't yet classified or understood. The legacy of Tabby's star goes far beyond a viral alien rumor. It is a perfect example of how science works. A surprising observation sparks wild speculation, but rigorous testing, data collection, and cross-checking gradually narrow down the truth. It also highlights the power of citizen science, ordinary people, helping professional astronomers make discoveries that machines miss, and shows how even the most far-fetched ideas can drive meaningful scientific progress. The alien megastructure rumor may have been what grabbed the world's attention, but the real story is far more inspiring. We live in a universe where a single distant star can teach us new physics, challenge our assumptions, and keep our sense of wonder alive. Tabby's star also reminds us of our place in the cosmos. It is easy to get excited about the idea of advanced alien civilizations building giant structures around stars, but the truth of natural cosmic phenomena is just as amazing. A cloud of interstellar dust, trillions of kilometers across, shaping the light of a star 1,400 light-years away, is a breathtaking reminder of the universe's quiet grandeur. We may not have found alien megastructures here, but we have found something equally valuable, a deeper understanding of how stars and planetary systems evolve, and a renewed motivation to keep looking, keep questioning, and keep exploring the endless mysteries of outer space. Every time we point our telescopes at the sky, we uncover new puzzles that push the boundaries of human knowledge. Tabby's star is just one of millions of cosmic enigmas waiting to be solved. Stars that behave strangely, galaxies that collide, black holes that warp space-time, and planets that might harbor life as we don't yet know it. This star's story is a testament to the curiosity that defines humanity. We don't just look at the stars. We want to understand them, to decode their signals, and to uncover the hidden rules that govern the entire cosmos. As we continue to launch more powerful telescopes, design more sensitive detectors, and expand our exploration of deep space, we will undoubtedly find more stars like Tabby's star objects that confuse us amaze us, and make us rethink everything we know. And while we may not find alien megastructures anytime soon, every discovery brings us one step closer to answering the biggest question of all: whether we are truly alone, or whether the universe is teeming with life in forms we can barely imagine. For now, Tabby Star remains one of astronomy's most beloved puzzles, a symbol of the unknown that keeps us looking upward, wondering and exploring. It teaches us that the most exciting stories in space exploration aren't always the ones we expect. Sometimes they re the strange, the unexpected, and the beautifully unexplained. The universe is vast, infinite, and full of secrets, and Tabby Star is just the beginning of our journey to unlock them all. Please like, comment, share, and subscribe to the channel